tricky, okay? Like, look, I'm going to make a magnetic field for you people. You have to apply left hand rule to decide where this particle goes, okay? Chale. This is the south pole, this is the north pole, okay? Who's there? Zariyab is there. Okay, so magnetic field का जो pattern है, that's from north to south pole, okay? Now I'm sending three radiations from here, तीनों. तो मैं यहाँ पे लिखता हूँ all three radiations, अच्छा, all three, alpha, beta and gamma. अस्सलाम वालेकुम ज़रियाब. अच्छा, ज़रियाब आवाज आ रही है आपको मेरी?
वालेकुम अस्सलाम सर.
ओके ओके ज़रियाब, गुड मॉर्निंग.
जी सर.
अच्छा, लेफ्ट हैंड रूल बच्चों आपने अप्लाई करना है और आपने बताना है कि ये पार्टिकल अल्फा बीटा गैमा मैग्नेटिक फील्ड में rather they go straight, rather they go out of the screen, rather they go into the screen. Left hand rule, father mother child, field motion current. तो first of all आप एक काम करें, first of all you just apply this rule on alpha particle. Imagine the alpha particle is coming, your first finger should represent left हाथ की पहली उंगली, first finger of your left hand should be north to south. Middle finger should be aligned with the alpha particle with green line. Open your thumb. Left hand rule लगाएं. First finger north to south.
Alpha particle will go out of the page.
Out of the paper आ रहा है. Very good. Fatma got it. मिशाल apply करें. Left hand rule. Apply करें. North to south is your field. Left to right alpha particle is coming. Middle finger. Open your thumb.
It's going out of the
Very. So I'm writing the result over there. Alpha is basically going out of page, out of paper. Okay. सही है. Here. अच्छा, ये नहीं कि you have to memorize out of the paper. In this scenario, it is out of the paper. Maybe in some scenario, it will be into the paper. लेकिन यहाँ पे it is out of the paper. Okay. ज़रियाब लेफ्ट हाथ की पहली उंगली आपने नॉर्थ टू साउथ मैच करनी है. मिडिल फिंगर लेफ्ट हाथ की लेफ्ट टू राइट मैच करो ग्रीन लाइन के साथ. मिडिल फिंगर तो फर्स्ट फिंगर नॉर्थ टू साउथ, मिडिल फिंगर ग्रीन लाइन अल्फा के साथ. यू कैन सी अल्फा इज आउट ऑफ द पेपर. ठीक है, चेक करो सर आप.
यस सर.
अच्छा, अब बीटा के लिए इफ द बीटा इज कमिंग फ्रॉम द सेम साइड, द बीटा पार्टिकल, but middle finger should be against the beta particle. You always have to oppose the beta particle by putting middle finger against the beta particle. So once again left hand rule लगाना है, no need to apply right hand rule. तो लगाएं left hand rule. बीटा के लिए against the green line करें. Flip your hand. थोड़ा सा मुश्किल होएगा. North to south first finger, middle finger against the beta toward left side, against the beta.
सर into the page
आ रहा है. ओके, मिशाल आदम चेक करें. चेक करें, into the page आ रहा है.
Yes, sir. It's coming into the page.
It's coming into the page, and the gamma definitely goes. Gamma goes straight without any deviation. So this is deflection of how magnetic field is going to affect the motion of a charged particle. Adam, if you have any confusion applying left hand rule on these three charges, where the gamma goes straight, alpha ke liye you have to align, beta ke liye you have to flip. Middle finger is basically the motion of charged particle. Fatma, clear? Adam?
Yes, sir.
Say yes if you're clear.
Yes, sir, I'm clear.
Okay, you're clear. Achha. Now, next topic is half-life. This is a topic most of the students इसको जरा scary होते हैं, ठीक है? अच्छा, half-life is this. Let's suppose Adam is a nuclear scientist and he's having a detector, okay? Ziyab and Adam, they're friends and they're working in a lab and they're having a detector. This detector name is GM tube. This is known as the GM tube, but आपको GM tube ना भी याद रहे, you have to remember a name detector. Achha, what it does, any radiation like alpha, any radiation like beta, any radiation like gamma, if gonna hit it, there is a screen which gives the number. Let's suppose 30 counts are hitting per second, 50 counts are hitting per second. ठीक है विशाल? अच्छा, अब आपने क्या करना है? You have a radioactive sample that is, in a cage like this. This is a lead box. This is a lead box. Now, here is a radioactive sample known as the radioactive sample, very hazardous. ठीक है? Very, very dangerous. Okay. That's why it is stored in a lead box so that radiation do not go out. Acha, let's suppose there is a lock or a door over there. There's a door over there, and this is locked. Okay. It means now no radiation are coming out. Clear? ठीक है. Acha. Now, Adam is going to turn on the detector. Adam have seen some radiations are coming from the background, not from the source, but 30 counts basically, 30 counts per second. Adam has detected. Mishal said, Zaryab said, oh my God, why you are having 30 counts, although there is no um sample. Sample is purely locked in the cupboard. Why the radiation are coming, bache? Hmm? From the sides. What do we name them? ये जो a little bit radiation coming
Background
from.
radiation.
Very good. इनका नाम है background radiation. I hope you don't mind if I write BR. Background radiation. Achha, background radiation can vary. Maybe in Islamabad they might be 25, 28. Maybe in Ahmedabad they are 32, 33. Maybe in Balochistan they are 84, 85 even. Background radiation are from food, volcanoes. मैं यहाँ पे लिख देता हूँ background radiation कहाँ से आती है. फूड से आ सकती हैं, ओवन में जो खाना हीट अप करते हैं उससे आ सकती हैं, वॉल्केनोज से आ सकती हैं, सॉइल से आ सकती हैं. ओके, बट देयर आर सम बैकग्राउंड रेडिएशन, दे आर ऑलवेज प्रेजेंट अराउंड अस. ये बात कंफर्म होगी. अच्छा, बट नाउ इट्स द टाइम टू ओपन द गेट. द मोमेंट वी ओपन दिस गेट, now the radioactive radiation alpha beta gamma are coming. Now this 30 counts, let's suppose the 500 is added. Now the total number of radiations are how much? 530. Okay, Mishal Adam? जरा आप देखो 530 होगी ना. So how many coming from the radioactive source? बोले, how many coming from the radioactive source?
Sir, 500.
500 counts per second are coming from the source. How many coming from the background, Mishal?
30.
30. Now we have to check the half-life of this radioactive sample. Let's suppose Adam and Zaryab, they went outside for 20 minutes. For 20 minutes, T half means for 20 minutes, if they go out and they believe that this is the half-life of the sample. Yani 20 minutes ke baad, they think radiation coming from the radioactive sample should be half. So what they have done, they have calculated 500 divided by 2. What's the answer? बोले, what's the answer? फातिमा, कितना आंसर आना चाहिए?
250.
250. Very good. But 250 should be the reading on detector, but unfortunately, a little bit background radiation they again entered. Like two friends are talking ना, आपने अक्सर देखा होगा तीसरी फ्रेंड आके वैसी खड़ी रहती है पास. Although she is not your friend, but she's hearing your gossips. है ना Mishal? Mishal feel very bad कि यार I'm talking to someone special. Why the third person is coming? Background radiation are exactly like this. So that's why you detect total 280 counts after first half life. How many counts? 280 counts. Adam, समझ आया?
Yes, sir.
So initial count was how much, Adam? 500 from the source.
Yes, sir. 500.
Yeah, if you divide by 2, you will get how much?
250.
But why we have added 30 again?
Because of the background radiation.
Background radiation. Okay. For next 20 minutes, next more 20 minutes. After more 20 minutes, they went back. They go outside again. Fatima, अब कितनी radiation आएंगी? Think about this.
250 divided by 2.
Yes, 250 divided by 2 करेंगे. Your answer is 125 plus once
That's
again क्या ऐड हो
30.
जाएंगे? Background radiation ऐड हो जाएंगी. 155. You're getting this? The very important concept is, Mishal, you have to subtract background radiation first, then you have to take the half. This is really, really important. Including background, you cannot take half because background half nahi hoti. Whenever Mishal wanted to talk to the friend, There are always 3 to 4 people around Mishal. Mishal को गुस्सा आता है. Why they're here? Why they're hearing me? हाँ, their background noise. Okay, Mishal? ठीक है?
Okay,
So,
sir.
so let's have a puzzle now. Let's suppose there is a sample. Chalo, now no background. Chalo. Now for a minute we assume there are no background radiation. Okay, so that you will get the better idea first. No background radiation. If there are maximum counts 1000 counts per second and half life is 20 minutes, how many reading you will have? Half life is 20 minutes. How many you will have after 1 hour? How many counts per second after 1 hour? सोचें जरा आप जरा सोचें 1 घंटे बाद कितने काउंट्स आने चाहिए. इग्नोर बैकग्राउंड रेडिएशन. इनिशियल काउंट रेट मैंने दे दी है. दिस इज द इनिशियल काउंट रेट. ओके, नो चार्जिंग. बाद में आना 10 minutes बाद. Hurry up. How many counts you will observe after 20 minutes? If it's the half lifetime. Sorry, 20 minutes the half lifetime. How many counts you observe after 1 hour? Do divide, शाबाश. Hurry up. 1000 को कितने टाइम डिवाइड करना है? 1000 by 2, one answer. Then 20 minutes के बाद 40 minutes. फिर डिवाइड by 2, then 20 minutes. 60 minutes.
125 counts per second.
125. फातिमा का आंसर आ गया 125. लेट्स सी मिशाल का क्या आंसर आता है. मिशाल देखो, आपको पता है कितने? मिशाल फर्स्ट 20 मिनट्स के बाद यू हैव टू हाफ, देन 20 मिनट्स, तो 40 मिनट्स हो गए. हाँ मिशाल, 40 मिनट्स देन 20 मिनट्स मीन 60 मिनट्स. सो 1 hour पूरा हो गया मिशाल. लुक, सो हाउ मेनी टाइम यू हैव टू मेक इट हाफ? 3 टाइम्स. हाउ मेनी टाइम्स? 3 टाइम्स मिशाल को हाफ करना है. सो मिशाल इसको हाफ करते हैं 3 टाइम्स. फर्स्ट टाइम यू मेक इट हाफ, व्हाट कुड बी द आंसर? यस मिशाल, व्हाट्स द आंसर? 500. फिर हाफ करो मिशाल. सेकंड टाइम आंसर इज 250. Then make it half again. Last time answer is 125. Please feel free to ask anything on the Mishal Zaryab. I think Fatima understand this. Hurry up. Yes, Mishal, is there any confusion?
No, sir.
You got it? Why I did half 3 times?
Sir, because 1 hour.
Yeah, 1 hour contain 20 minutes ke 3 sessions, okay? 3 half lives. Okay, how many half lives? 3 half lives. Each half life consists of 20 minutes. So right after 20 minutes, 1000 ka half, 500. Then 20 minutes, 500 ka half, 250. Then further 20 minutes, you will get 125. Okay? But if there is a question with 30 background radiation, then you have to add background again. Let's suppose 30 are the background radiation, okay? At the end, you add background again, you will get 155 answer. If there are 30 background, okay? ठीक है? अच्छा, Adam, you got it? Adam?
Yes, sir, I got it.
Acha. So what's the formula for this? The formula is if you know the total time in hours and you divide it with the half-life of time, you will get the number of half-life. Number of half-life means how many time you get half. That's why if I do this, total time is 60 minutes, half-life is 20 minutes. That's why the total answer, total number of half-life is 3. Means Mishal got it, Fatma got it, 3 times हमें half करना है. How many times? 3 times. Means calculator पे initial count को divided by 2 1 time, divided by 2 2 time, divided by 2 3 times. Okay? Acha, how many counts have been decayed in this? How many counts या atoms have been decayed जो vanish हो गए, खत्म हो गए? जरिए आप देखो 1000 में से माइनस करो 125 are left basically, Mishal. So how many have decayed basically? 870. बोले Mishal, 870.
Sir, 875.
Yeah, 875 atoms are counts. They are completely destroyed, vanished, decayed. Okay, that's why they're left. Got it? So once you do half, 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 after this, whatever the left is this, you have to subtract from the total. This is how Mishal you will get how many atoms completely decayed. Okay, got it? Acha. Sometimes there's difficult for you to understand background radiation. तो उसके लिए मैं आपको एक लॉजिक बताता हूँ. If you have been given this thing, like Adam turn on the detector, there was no radioactive sample in the room. Adam detect like this: 28, 30, 31, 27, 30, 24, 30, 34. So how you get to know कि out of these which one is exact background radiation? You have to pick only one. Hmm? Because background radiation are random in nature, Fatma. They fluctuate. Background radiation are never ever constant. If your room contains some background radiation, they are random in nature. Like Mishal is talking to someone, it's not necessary every time 3% is hearing his gossips, her gossips. Maybe there are 3 people in the background, there are 4 people in the background. So background radiation are always random in nature because the people who are here to listen to your gossips, they are basically they vary. है ना, Mishal? So out of these, how we get to know which one has the most repeated value? But Mishal piche murti hai. Every time if she have seen some people again and again over there, it means they are basically background. They always want to hear gossips. So सबसे ज़्यादा repeat कौन सा है देखते हैं. Look at this. 30 एक दफा, 32 times, और even चलो इसको 30 कर लेते हैं इसको भी. 33 times. So 30, 31 approximately, these are the background radiation. The most repeated value you have to select, they are the background radiation. Okay? Zaryab समझ आया? Zaryab?
Yes, sir. Yes.
Acha. How to find now half-life from the graph? If you have any confusion, do let me know please बच्चों. अब मैं ग्राफ से half-life सिखाता हूँ. आदम विशाल ग्राफ. फातिमा क्लियर?
Yes, sir.
आदम any confusion? पूछो बच्चे.
No, sir, I'm clear.
Good. अच्छा. Half-life का graph is like this. On y-axis, basically you have counts per second. And here is, let's suppose, time in minutes, hour, days, कुछ भी. Minutes, hours, days, even years. ठीक है? Right now I'm doing 2 minutes because आपको 20 minutes वाली बात याद है. Now let's suppose these are the maximum counts known as 1000. ये इसका half हो गया 500 और ये आ गया 0. सही है? ठीक हो गया? अच्छा, these are the time 20 minutes, 40 minutes, 60 minutes, 80 minutes, like this. ठीक है? Okay. So first of all, the count rate will be 1000, let's suppose. Initial count rate from the sample, initial count rate maximum is 1000. Okay. Let's suppose it is 1000. And Adam कहता है half life is 20 minutes. 20 minutes. अब ग्राफ से कैसे करना है? You have to do like this. Wait. Like this. 20 पे, if the graph is like this, yeah, like this. So exam में question आ गया, find the half life. It's not given. Let's suppose this is not given. Find the half life through this graph. Fatma, Adam, Mishal, what we can do? हम ग्राफ से कैसे निकालें half life? I don't know what is half life. What we do? Mishal, हम इस तरह करते हैं, 20 से ऊपर आते हैं, चेक करते हैं. ओहो, थोड़ा सा मैंने ग्राफ गलत बना दिया. A little bit wrong. Sorry. Let me make it again. Wait. Yeah, now see. See बच्चों, 20 से हम ऊपर आते हैं, see ऊपर आके yeah. Here it is touching, and if you go to the left side, oh, 1000 count are reduced to 500 in how much time? देखो, 1000 count Mishal, they are reduced to 500 in how much time?
Sir,
Look,
20 minutes.
20 minutes. So that's why the half life of this radioactive sample is 20 minutes. So this is the first half life. This is your First half life time. Now see, this is 250. If you go again and touches the graph, see this. Oh, next 20 minutes में क्या हुआ? 500 का half हो गया. So, Fatma, 1000 by 2. Answer आ गया कितना? 500. And then 500 by 2. Once again, 250. It means this is your first half life, first 20 minutes. And then after 40 minutes, you should have this count. I समझ? Acha. Now you will keep on doing this. After some time, the line gets straight. And let's suppose you have only 30 counts per second. Why? Why the line is flat at 30 counts per second? Why the line is flat over there? You can see the blue line is flat. They are known as bole. They are known as
Background radiation.
background radiation. If examiner asks you why the line is flat after some, तो आप बोले all of the radioactive sample has been decayed. ठीक है? All of the atoms has been decayed. It means no more counts are coming from the radioactive sample. They are only background radiation. They are only background radiation. Actually, examiner might ask you why there are some points above and below the background radiation. So you have to say background radiation are not fixed. They are always random in nature. The person who is hearing Mashal's gossips, those ladies or those classmates are not 2, 3. Sometimes they 4, sometimes they 3, sometimes, they vary basically. That's why the background radiations, they always vary. So they are 30. Got it? How to find the half-life? Adem, Mashal, Fatma, please share your feedback, bache.
Yes, sir.
Yes, sir. We got it.
Got it? Very good. Very good. Acha, one last thing. Alpha decay and beta decay को मैंने पढ़ाया था. जल्दी से quickly आप इसको से do complete this equation. If you have the uranium and you have an alpha particle which is being out, what is the atomic number and mass number of the new element? Be quick, shabash.
Sir,
232 and 90.
232 सही है. Okay, जरिया बोलो.
sir, 236 subtracted 4 and 92.
92 में से 2 minus कर देंगे. Really good. Really good. If you have a beta particle, like if you have isotope of sodium and it's going to emit a beta particle, okay, then what's the new element? Why? What I have to write? क्या बताया था मैंने? Whenever this beta decay,
24 and
Sir,
12.
24 will be the same.
yes, definitely. Good. And
And you'll add 1 to 11, so 12.
this is? Yes, Hanan?
12.
Okay, Hanan, wait. Excellent, Bache. You are right. You are perfectly right.